Okay, I had a comment that on the range for the electric car that we should use 12 volt batteries instead of 26 volt batteries. The 12 volts, 12 times 12 would be 144 volts, which is okay. And 6 times 20 would be 120 volts. But it isn't voltage we're concerned about here. It's kilowatt hours. And kilowatt hours are the voltage times the amperage. This is what we look for. So in order to get the same kilowatt hours, I would have to have 16 12-volt batteries, which would put me up to 192 volts. That would maybe be a little higher than I'd want to be, and most controllers won't go that high.
Okay, to make a comparison between 6 and 12 volt batteries, we need to compare kilowatt hours. If you look here, I've highlighted this, it doesn't show up very much, but the T105 is a 6 volt battery. Weighs 62 pounds, that's right over here. And the kilowatt hours, which is a 100-hour rate, is 1.5. Okay, there's 1.5 kilowatts, which is total power. That's voltage times amperage. Now, if I look down here, I've got a 12-volt battery right here. And the kilowatt hours on it are 1.86. Okay, and it weighs about 78 pounds, because it's a little bit heavier. Okay, but there's not a lot of difference in the kilowatt hours between the two batteries. So if I use 12 volt deep cycle batteries or 20 6-volt deep cycle batteries, let's make a comparison and find out exactly what the kilowatt hours would be on them. Okay, hopefully this little sheet will make sense. Let's go over the top of this. If I use 6-volt batteries, they're 1.5 kilowatt hours, and I use 20 of them, I'll get 30 kilowatt hours. And that's total power. Remember, voltage times amperage is kilowatts. If I use 12 volt, they're 1.86 kilowatt hours per battery. I would need 16 to get 29.8 kilowatt hours, which is essentially would be the same as the 20. The 6 and 12 volt batteries are about the same size. What that means is, because the 12 volt battery's got twice as many cells, meaning it's 2 or 2.2 volts per cell, it's got 6, where the 6 volt only has 3. Now that it's kind of important, because these plates being closer together like this, they're going to warp easier. And they warp because they overheat when we're under high discharge. Now these things discharge fairly fast when you're running a car, especially if you're accelerating or going uphill. And if the plates warp, they break and they fall apart. So the 12 volt battery being about the same physical size as a 6 volt, it's not going to dissipate the heat as easily. So 6 volt batteries make sense in this case. The kilowatt hours is what you're looking for. Now if I did as this shows, to get the same kilowatt hours out of both these battery packs, the 6 volt would be 120 volts, and the 12 volt would be 192. If you can use 192, it's okay. A lot of the motors aren't really designed for that high a voltage. And the higher the voltage, the more problems with brushes you have. You need voltage. You need voltage to push the amps through. But that's maybe a little bit high for a lot of applications. I hope this makes sense. That's that kilowatt hours is what you're looking for. And to get that same kilowatt hours, you're going to have to use more batteries with 6 volt than you do with 12 volt, but because the batteries are larger, they will dissipate heat faster when they're discharged, or even when they're charged. It's the same situation. So that's why we use 6 volt. It doesn't mean you can't use 12 volt. I've seen guys do it, and it does work. And some of the more expensive batteries, lead acid batteries, what I'm talking about, some of those actually work fairly well, but they're so much more expensive than your golf cart batteries that it may be an issue when you're trying to build a car. I think my battery pack cost
around, I believe it was $1,600.
And if I was to use high-end lead acid batteries, I'd be looking at maybe 2 to 3 times that much. So that's why it's done that way. You cannot increase range simply by using 12 volt batteries, because you won't have the kilowatt hours. If I used a smaller number of batteries at 12 volt, that would not mean that I would get the same kilowatt hours. I hope it makes sense, but that's my explanation on it.
Okay, before I leave this thing, I wanted to make a comparison of these battery weights. So if I had 6 volt batteries and I was using 20, they're 62 pounds a piece. So 20 times 62 is 1240. If I had 12 volt batteries, they weigh 78 pounds, and I would need 16 to get the same kilowatt hours. So I end up with 1248. So I really don't have a lot of difference in weight per kilowatt hours. And I don't think you would really gain anything by putting smaller numbers of batteries in there, because you'd simply lose the kilowatt hours. So that's pretty much it on the batteries and why we're using what we're using. And any comments are welcome.